Hey guys, this is the first of the actual content related podcasts that I'm going to do. It's going to cover some of the content in Chapter 8, Section 1 on perimeter formulas. All I'm really going to do for this one is I'm going to cover three of the questions that are in the homework. That'll be question 10, question 11, and question 17. The first of them is question 10. It's dealing with this figure right here. In the book it says the perimeter of a rectangle is 70. One side of the rectangle is 3 times the length of the other, or the lengths of the sides. So basically the way you set this thing up is here's a rectangle. Just pick a variable for one of the sides. We'll just call it x. So if that side is x, the other one being 3 times as big's got to be 3x. So there's the x again, there's 3x. Okay, so to figure out what our perimeter or what x is supposed to be and the lengths of our two sides, we've got to set up a little equation. Well, a perimeter formula for a rectangle is 2 times the length plus 2 times width. That gets you your perimeter. And in this case, our length is x and our width is 3x. So we plug those in and we know the perimeter was given in the question is 70. So we have 70 equals 2 times x plus 2 times 3x. So we just got to do a little bit of algebra and simplify that stuff. So we got 70 equals 2x plus 6x. So 70 equals 8x. And then what we need to do is divide both sides by 8. And that'll give us our x. So 70/8, if you guys, I know you don't like fractions, that's 8.75 as a decimal. So then to figure out the length of the other side, so it being 3x, we'd have to take that thing and multiply it by 3, and we get 26.25. Alright, the second question I'm going to cover it's pretty similar. It's question number 11. This is what this one looks like. It's still, we got a rectangle, we got a poster. We're not being all that original. It says the posters be 1.5 times as wide as it is high. Well, we just call the height h. Well, 1.5 times the height is 1.5h. Okay, and it says if its edges total 3 meters in length, we want to know how wide the poster is going to be. So how wide the poster is going to be, we want to know how long this top side is. Okay, so like the other one there. Okay, we've got our perimeter. Again, this one has to be 3. Then we've got one side we know is h. So because we have to do 2 times that height, so that's going to be 2h. Plus 2 times the top. The top was, if you look back here, 2 is 1.5h. So 2 times 1.5h is 3h. So just like up there, we're going to simplify the thing on the right side. We got 3 equals 5h. Divide both sides by 3. Or by 5, I'm sorry, 5. And you get h to be 0.6 or 3/5. Okay, but that's definitely not our answer. Because we want to know how long the top part is, and the top was 1.5h. So what we need to do is take this number and multiply it by 1.5, and we get 0.9 meters. Okay, now the last one I want to cover is question 17. It says a rectangle has a perimeter of 16, and it said graph all the possible pairs of lengths of x and y. Okay, so basically if we plugged all the information in our perimeter formula, are we given our perimeter is 16, and we've got one side is going to be x, so that we plug that in, we get 2x. The other side's the length is y, so that's 2y. Okay, but that formula is kind of bothering me a little bit, so because I can divide everything by 2, so I'm going to do that. I'm going to get 8 equals x plus y. So basically what this question is asking you to do is graph all the different possible pairs of numbers x and y that add up to 8. This is what it looks like over here on my little graph and sketch pad. I already graphed a few of them for you. These are the integer pairs. Like this point right here, this is what x is 1, y is 7. Obviously that adds up to 8. Here's 2 and 6, 3 and 5, 4 and 4, and so on. We just keep going. But if you look here, I didn't put a dot here on the x-axis or the y-axis. I didn't put a dot at 8, 0, because if you think about it, that would mean one side of my rectangle has to be 8 whatever units long, and the other side would have to be 0, which is impossible. We wouldn't have a rectangle anymore. So if you were to graph this, what you'd have to do is put an open dot on 8 and an open dot and 8 on the y-axis here too. What about this junk in the middle here though? Can you have fractions for sides or decimals for sides? You bet you can. So what you'd have to do here is from this open dot at 8 and from this open dot at 8, you'd want to draw a segment that goes through all of those. And again, these two spots would have to be open, but it could be any different one of these little fractional amounts on this line. So those are all the possible pairs of lengths and widths for this rectangle. Okay, and actually part B of it we already answered figuring that out. Here's an equation for that line. This is in standard form, x plus y equals 8, or I take this to 2x plus 2y equals 16. They're both the same equation basically. And for part C it said find one possible length and width where both are not integers. What that's saying is you want one possible length and one possible width that's got basically a fraction slapped on it or a decimal at the end. So what we'd want to do is find one of these ordered pairs that isn't on one of these nice little integer coordinates here. So like one of them, if you look here, this looks like about 4.5 and 3.5. Or we go up to 2.5 and 5.5. Just pick a couple random things with decimals and fractions on them to add up to 8. And that's about it. And again, if you got any suggestions or if there's anything else you'd like me to add or change, just tell me.